For the first time in a generation, humanity is getting ready to journey beyond the cradle of Earth, to really reach out and touch the cosmos again. We are going back to the moon. It's been over 50 years, seriously, half a century, since the crew of Apollo 17 left the last human footprints on the lunar surface, way back in 1972. Ever since then, nobody has left the relative safety of low Earth orbit. And just so you know, that's kind of like our cosmic backyard. It's where the International Space Station hangs out, just a few hundred miles up. But that's all about to change. With the Artemis program, we're not just, revisiting the past. We're actually building a whole new future. This is not a repeat of Apollo. This is the start of a brand new era of exploration. Right, so the goal of Artemis, it's not just about planting flags and taking cool pictures. It's about setting up a sustainable human presence on the moon. Think of it as a crucial stepping stone for the next giant leap, eventually sending astronauts to Mars. So the program is this really methodical multi-mission plan. The idea is to build a base at the lunar South Pole, and that spot is super interesting because it's rich with scientific potential and resources like frozen water, and that water could one day be used for rocket fuel or life support. It's all about learning how to live and work on another world. And of course, at the very heart of this huge undertaking are the people, the actual pioneers who are going to strap themselves into that capsule and write the next chapter of human history in space. So let's meet the crew of Artemis II. Leading the mission, we've got Commander Reed Wiseman, and alongside him is pilot Victor Glover, both really seasoned astronauts. They're joined by mission specialist Christina Koch, whose record-breaking long spaceflight gives them some crucial experience for deep space, and Jeremy Hansen from the Canadian Space Agency, which just goes to show you the global partnership that's driving all this. And they won't be totally alone up there. Get this, a small plush mascot named Rise is going to be their zero-gravity indicator. It's this really clever nod to that iconic Earthrise photo that was taken during the Apollo 8 mission, and it's a great way to connect this new generation of explorers to the absolute legends who came before them. Okay, let's dive into the mission itself. Now, it's really important to know this is not a landing. This is a critical 10-day test flight. It's all about pushing the hardware to its limits and making sure every single system is ready for humans in deep space. So, how is this journey actually going to unfold? Well, it's a very carefully choreographed flight plan, all designed to test the spacecraft's capabilities and, most importantly, bring the crew home safely. The whole mission really breaks down into 4 key phases. It all kicks off with that thunderous launch and ascent. After that, they're on the trans-lunar coast, which is a 4-day trip out to the moon. Then comes the main event, a truly breathtaking lunar flyby. And finally, the super high-speed re-entry and splashdown right here on Earth. Now, what's really fascinating here is the flight path they're taking. They're using what's called a free return trajectory. Basically, this means they use the moon's gravity to do all the heavy lifting, kind of slingshotting the Orion capsule around the far side and aiming it straight back home. It's an amazing safety feature because it helps get them home even if there's an engine problem. And during that lunar flyby, the crew will be about 6,500 kilometers, or just over 4,000 miles, above the far side of the moon. They are going to travel farther from Earth than any human in history. They'll actually be breaking the record set by the crew of Apollo 13. Okay, let's move on and look at the incredible technology that makes a mission like this even possible. We're talking about the most powerful rocket ever built and a state-of-the-art deep space crew capsule. So here we have the 2 key pieces of the puzzle. On the left is Orion, which will be the crew's home for their 10-day journey. And on the right, you can see the mission patch, which really beautifully symbolizes that whole trip, leaving our blue marble, looping around the moon, and coming safely back home. Orion is purpose-built for deep space, and one of its most critical parts is its heat shield. See, coming back from the moon means you're re-entering Earth's atmosphere at insane speeds, and this shield is the only thing that protects the crew from the extreme heat generated by that. Now, to get Orion on its way requires a truly staggering amount of power. The Space Launch System, or SLS rocket, generates 8.8 million pounds of thrust at liftoff. That is more power than any rocket in history. And that raw power is exactly what makes the SLS so essential. Right now, it is the only rocket that can send the Orion capsule and its crew directly to the moon in a single shot. It truly is the foundation of the entire Artemis program. So, Artemis II is a vital step, but it is not the final destination. This flight is all about proving the system's work and paving the way for the missions that will finally put human boots back on lunar soil. And you can see the roadmap right here. It's a step-by-step approach. Artemis II tests the life support. Then Artemis III will practice docking with the lunar lander. And then Artemis IV. That will be the historic mission that finally lands astronauts near the moon's south pole. But the vision doesn't stop there. The ultimate goal is to build a permanent outpost on the moon, a lunar base that will allow for long-term science, for using resources we find there, and it will serve as a training ground for the eventual human exploration of Mars. So you see, this isn't just one mission. It's really the dawn of a new age of discovery. We are literally witnessing the beginning of a sustained human presence in deep space, and it's a journey that's going to redefine what's possible and expand our understanding of the whole cosmos. Because when you get right down to it, the goal isn't just to visit, it's to stay. We've got the technology, we've definitely got the ambition. The real question now is, how are we going to build a lasting future for humanity beyond the confines of our home planet?